Hello everyone, my name is Andrew Huezo and welcome to my Honors Geography virtual field trip. Over the course of this video, I'll take you on a tour across Southern California to some iconic natural landscapes, including some of my favorite hiking spots. Today we'll explore 4 different locations that represent each of Earth's major spheres: the lithosphere, atmosphere, hydrosphere, and biosphere. Let's begin our journey in the Santa Monica Mountains, where tectonic plates have shaped one of LA's most scenic hiking spots. Our journey begins at the Topanga Lookout, located in the Santa Monica Mountains at an elevation of approximately 2,375 feet. This is one of LA's most popular hiking destinations, as it's known for its wide views and unique graffiti-covered concrete lookout. The trail to the top of the lookout is about 2 miles round trip, making it relatively short and accessible for hikers. Along the way, hikers follow a narrow ridge with steep dropouts on either side, offering panoramic views of the San Fernando Valley and Santa Monica Mountains, which you can see guided by my pointer. The lookout itself is located at a section of uplifted sedimentary rocks, shaped by tectonic forces along nearby faults, such as the Raymond Fault. A million years of plate movement pushed these layers upwards, creating this elevated ridge we see today. The jagged edges and slopes we see around the site are a result of different erosion, where wind and water slowly wear down the softer rock, leaving behind a more rugged and uneven landform shown within this canyon. Overall, the Topanga Canyon shows how the lithosphere is continuously being shaped by internal forces like faulting and external forces like erosion. As a result of these forces, they craft scenic landscapes we are able to hike and explore today. Our second stop takes us deep into the Angeles National Forest to Sturtevant Falls, located in Big Santa Anita Canyon at an elevation about 2,640 feet. This is one of the most popular waterfall hikes in the San Gabriel Mountains, especially during the spring. The round trip of this hike is around 4 miles, which offers plenty of sights to see. The trail is shaded and lined with sycamore trees, moss-covered walks, and a flowing water stream that runs from the falls. As you hike deeper into the canyon, it becomes clear that the waterfall plays a significant part in shaping both the landscape and ecosystem here. When looking at the waterfall itself, it varies by seasonal rainfall, snowmelt, and groundwater. As precipitation falls in higher elevations, gravity pulls it downslope as a runoff, where then it travels over the cliff to Sturtevant Falls. This site overall shows the hydraulic cycle in action, as it shows precipitation, infiltration, and streamflow all work together to create Sturtevant Falls' water flow. Furthermore, the consistent water flow helps carve the canyon and shape sedimentary layers over time. In addition to shaping this land, this stream is a key resource to the surrounding biosphere, as it helps sustain the habitat of plants and animals within the region. Sturtevant Falls is not only one of my favorite hiking spots in Southern California, but a perfect example of how the hydrosphere supports and shapes ecosystems. Our third stop takes us to the Observatory Trails Peak in Griffith Park, located in the eastern Santa Monica Mountains, with an elevation of about 1,400 feet. Griffith Park is one of the largest urban parks in the United States, as it serves as a unique system for the park's local animals, as it balances aspects of both nature and urban features. As hikers and visitors go to the observatory trails, they often encounter a wide variety of wildlife, including the eastern fence lizard, mule deer, red-tailed hawk, and a coyote. Similarly, Griffith Park has a wide variety of plants, such as the coastal sage scrub, oak trees, yucca plants, and toyum, all adapted to this dry and rugged climate within these hills. Even though the park is surrounded by one of the mostly densely populated cities in the United States, the ecosystem of animals thrive thanks to natural adaptations to drought and seasonal fires and common human interactions. In summary, Griffith Park and the Observatory Trails Peak demonstrate the delicate balance between the biosphere, where plants and animals and climate and land interact together in a living system, as they constantly adapt to both natural and urban human environments. For our final stop, we head inland to Cajon Pass, a major transportation route located between the San Gabriel Mountains and San Bernardino Mountains, at an elevation around 2,600 feet. This narrow pass is not only used by highways and trains, but it's also a natural wind channel and a hotspot for one of Southern California's most extreme weather patterns, the Santa Ana winds. The Santa Ana winds are fast and dry and hot winds that blow from the inland towards the coast, especially during the fall and winter. They are formed from high-pressure air over the Great Basin as they rush southwest, creating lower pressure along the coast. As the air travels through the press, it gets compressed and heated by a known process as adiabatic heating. As the temperature increases, the humidity drops, creating conditions that are prone to start and spread wildfires. Because the topography of this canyon is very steep, with steep slopes on both sides, it allows the wind at high speeds to run through the pass, with winds sometimes reaching above 70 miles per hour. Based on this, it's clear that those living and driving through the Cajon Pass have a high risk of wildfires and are opposed to dangerous driving conditions. Overall, the Cajon Pass is a clear example how atmospheric pressure systems and terrain interact to combine to create strong winds that have an effect on local communities and the environment in Southern California. In summary, together these 4 stops show us how the lithosphere, atmosphere, hydrosphere, and biosphere all work together to shape the physical geography of Southern California. Thank you for joining me on my virtual field trip. I hope it helped you visualize how the Earth systems come together to shape our natural landscapes we live in. Thank you.